So in this video, we're going to work through one of the conservation of momentum problems that you're going to find in your packet. And if you can open up to activity 1 and look for the second problem. The second problem is the one I'll work through because it's a little bit more difficult than the first one. And it lets me think that if you can do the second one, you're fine in doing the rest of them. So we have a 2 kilogram red cart moving right at 3 meters per second, collides inelastically with a 1 kilogram blue cart moving left at 3 meters per second. So there's a lot of information here. Let's go ahead and draw what we see. So to start off with, we'll do the before. And for before, we know that we have a red cart, so I'll write red on there, and it's 2 kilograms, so I'm going to put a mass on there, and it says it's moving to the right, so we're going to draw those motion lines, and it tells me it's moving at a velocity of 3 meters per second. Alright, the next one we have is the blue cart. For the blue cart, it is 1 kilogram. So we don't add anything on top, and it says it's moving to the left at 3 meters per second. Now keep in mind, the right is positive direction, left is negative direction. We have a negative 3 meters per second. All right, so just a note for ourselves, the mass, remember, is 2 kilograms for the red one. The mass for this one is 1 kilogram. This is the before. So let's draw a bar chart for this one. So we have the red and the blue. We have velocity and mass. And keep in mind, because it's 2 kilograms, I need to make sure to have it be 2 boxes wide, because each width is representative of 1 kilogram. So we have 1, 2 kilograms. Remember that the height of the box represents meters per second, and so in this case we have 1 meter per second. We need to get it to represent 3 meters per second, and I'm sorry for the bent one. So we're going to have a total of 6 boxes with 3 stacked on top of each other to represent 1 meter per second, 2 meters per second, 3 meters per second. Now remember, the blue one is moving in the negative direction, so we're expecting these boxes to be moving in the down, or be represented in the negative region, and they are, the blue car is only 1 kilogram. Let's see if we can get this going. There we go. So it's only 1 box wide, and it's also moving 3 meters per second in the opposite direction. Now you notice that unlike the problems we've done before, the number of boxes here does not equal the number of boxes there, and that's fine. So let's just do a count of how many boxes we have. We have 6 boxes on the positive region, and we have negative 3 boxes in the negative region. That means in the after section, after this collision happens, we need to make certain to have 3 boxes. Okay, so because 6 plus negative 3 equals 3. So let's draw our bar chart. Remember velocity and mass. Remember the red one is 2 kilograms and the blue one is 1 kilogram. So let's go ahead and cancel these things out. It's one way of doing it. This one is negative, negative. We'll pretty much cancel out this one and this one. We're left over with 3 boxes. So we know that the red one is 2 boxes in terms of width because it's 2 kilograms, and the blue one, which is now, we've only got boxes in the positive region, must mean that it's in the positive region, is a box, just 1 box because it's 1 kilogram on there. So now let's count how many boxes we have. 1, 2, 3. Do we have 3 boxes as expected? Yes, we do. So this seems to be what we can predict will happen after they've collided. So let me just draw that out. And because it's an inelastic collision, we know that we have the red car connected to the blue car, and they are moving in the positive direction. That means they're moving right, and it looks like they're both traveling 1 meter per second. So let's take a look whether or not this is what we would see in the actual simulation. So what I'm going to have you do is I'm going to escape, or actually let's see. Okay, I'm going to escape this here, and I'm going to go into my website that I have linked for you and scroll down to where it says collision carts. And I can manipulate these masses and so forth and the velocities to represent what I wanted. So what I said was we have a 2 kilogram red cart, so you can adjust that using these buttons, and it's traveling at 3 meters per second. So I have that, but in case it's a different one, you would adjust it this way. You have, in this case, a 1 kilogram blue cart, and it's traveling negative 3 meters per second. So I click those. I know it's inelastic, and then I press start. Let's see whether or not our prediction is in fact true. So they're moving towards each other. They are colliding. And yes, in fact, they do actually travel 1 meter per second in the positive direction. So let's take a look at this mathematically. So we're going to move away from the video and now continue on with our calculations.